So goal today, I'm going to add 3 more exponent properties. So far we only have 2. The first one we said was anything to the 0 power is equal to 1. Except 0, right? So we just say x can't equal 0, right? So just anything other than 0 raised to the 0 power we say is 1. We also said, what do we do with negative exponents? We flip them. So that's the same thing as 1 over x to the a, right? And we make it positive a. Again, we kind of eliminate x is 0 from that as well, because if you had 0 in the denominator, you'd end up dividing by 0. So again, just technically speaking, we got to say these rules don't apply if that base number is 0. Okay? Our goal today, we're going to add 3 more rules. Rules 3, 4, and 5. So the first one deals with problems like this. 4 to the third times 4 to the fourth. If you see numbers with the same base like this, what do we do with the exponents? You add them. Do you know why we add them? What does 4 to the third mean? It means 4 times 4 times 4. Times, what's 4 to the fourth mean? 4, 4, 4, and 4, right? That's really all multiplication, isn't it? Well, that just means I have 7 4s. So yes, our next rule basically says if you have x to the a power times x to the b power, and you have 2 numbers with the same base with exponents, what's the only thing we have to do? We take the a and we add the b. Really, is that so? That would be a times b. It's not a times b, it's a plus b. Because if you just write ab, that means a times b. Yeah. Got it? Okay. Easy enough so far? Now, what that actually allows us to do, if you combine that with the last section, if I have a number like 4,219,300, and I want to multiply that by 12,010,000. That's going to be a giant number, isn't it? Probably too big for most calculators to even handle. So one thing we could do is we could put them both into scientific notation. What would this one be in scientific notation? Let's say 4.2, we'll just say 1. We'll put 19. We'll ignore the 3. Times 10 to the what power? 1, 2, 3, 4, 5, 6. Yes? Times, where do we want the decimal here? 1.201, right? Times 10 to the 1, 2, 3, 4, 5, 6, 7 power. This math problem now is all multiplication. This says take 4.219 times, I know we usually put an x there because it looks, that's how we typically write scientific notation. We put an x instead of a dot, but it's the same thing. It just means times 10 to the 6 times 1.201 times 10 to the 7th, right? If it's all multiplication, does it matter what order we do things in? We can do the cumulative property, which means I could change this and do the 4.219 times the 1.201, I could just multiply those two numbers. Your calculator should be able to handle that, right? Times 10 to the 6th times 10 to the 7th. What does your property say to do with 10 to the 7th times 10 to the 6th? That's 10 to the 13th, isn't it? All you do is add the exponents. Times, all I now have to do, Tom, you got your calculator out. What is 4.219 times 1.201? Just times those two numbers together. $5.067. There's your answer. There's your answer in scientific notation. If you wanted to take it out, what's the only thing you'd have to do? Move the decimal 13 times to the right. So what scientific notation combined with this first property allows us to do is it allows us to multiply really, really, really big numbers and really, really, really small numbers very, very easily. If I want to do, let's say, whatever that number is, times that number. That's a giant number times a tiny number. Put it in scientific notation. This would be the same thing as 2.1 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Times, I'd want it at the end, right? 2.0, or just 2, times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, negative 13. Now, what's the only thing I have to do? What's 2 times 2.1? 4.2? Times 10. What's 12 plus a negative 13? Negative 1. And I can take it out of scientific notation. That's the same thing as 0.42. Done. So the combination of scientific notation with our new property, where all we have to do is add the exponents if the base are the same, one of the uses is it helps us multiply really big or really small numbers super easily. Make sense? And again, like this problem right here, most basic calculators can't do this. Why can't a basic calculator do this problem? The screen's too small. It doesn't have enough room to type all those zeros in. So if you have that situation where you have a calculator where it doesn't allow you to type that many zeros in, here is a very, very simple way you can do that. Make sense? All right. The next property helps us deal with powers raised to powers. So if I have 2 to the 3rd power, but that itself is raised to the 4th power, what does this 4th power mean? This means how many 2 to the 3rds do I have? It means I have 4 of those, right? But now I have a property that lets us deal with, I don't even need all the parentheses, 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. What's that property tell us we can do with all of these 3's? Add them together. What's 3 plus 3 plus 3 plus 3? So, what do you think the property is that allows us to deal with powers raised to powers. What do I do with the 3 and the 4? 3 plus 4 is 12? You multiply those. So rule number 4, you can add to your notes, is if you see a base that's raised to a power, and then that is also raised to another power, what do you do with your exponents? You just multiply. And that one would be AB. Simple enough? So what would you do if I gave you 2 to the 3rd raised to the negative 5th? What would you do with that? What's the first thing you should do with that? What do you do with powers raised to powers? You'd multiply, so that'd be the same thing as 2 to the negative 15. But what do I do with negative exponents now? You flip them. So that is the same thing as 1 over 2 to the 15th power. And once you flip it, you switch it to positive, right? In a second, I'm going to give you a list of things that you have to make sure. So our goal today is twofold. 1, I'm adding 3 new properties. 2, I'm going to give you some basic rules of what we have to eliminate in order to be simplified. You're going to be given some problems where the directions are simplify this expression. Well, by going from here to here, did I simplify it? Yes. I just didn't simplify it fully. So there's another step I have to do. One of those rules is going to be, are we ever going to be allowed to leave a negative exponent in our final answer? No. So because there's something else we can do to that. To me, it's the equivalent of reducing a fraction like 4/8. Does 4/8 equal 2/4? Absolutely. I just reduced that fraction, didn't I? Did I reduce it fully? No, because you can go further. Okay, so that's kind of what we're going to be doing in a second is we're going to be simplifying expressions, and sometimes you can do everything in one step. Sometimes you have to do things in 2 steps and use 2 different rules. Like this one, first we use the rule where we multiply the exponents. Then we use the rule where what do we do with negative exponents? Flip them. And does it matter which rule we use first? If we use the rule where powers raised to powers, we multiply, then we use the rule where negative exponents we flip, we get that power, we get that answer. What if I did it backwards? I have a negative exponent right now, don't I? Could I enforce the negative rule right now and flip it? Sure. What I would get is 1 over 2 to the 3rd raised to the positive 5 power. Right? Negative exponents just mean I flip it. So I take that whole thing and I put it in the denominator. Now I use the rule, what do you do with powers raised to powers? So does it even matter what rule I enforce first, which one I do second? No. You can enforce any rule you want at any time as long as you don't break a rule, like adding when you're supposed to multiply or something like that. Simple? All right. 3rd rule deals with problems like this. What do you do when you have multiple things under the same exponent? What does this 4th power mean? What does 2x, in parentheses, raised to the 4th power mean? It means I have 2x times 2x times 2x times 2x. How many 2's do I have? That means I have 4 2's. How many x's do I have? 4 x's. So the rule is when you have multiple things under the same exponent, you can almost think of it like I can distribute. Because there's going to be the 2 gets 4 to the 4th power, and the x gets a 4th power. So the rule basically is this. Rule number 5. If you have an x and a y, 2 things, or 3 things, or 4 things, all raised to a power, all you do is you kind of distribute. The x is going to get raised to the power of a, and the y is going to get raised to the power of a. Everything inside the parentheses gets raised to that power. Does that make sense? So, here's a tricky one. What would you do if I gave you 3 x squared y to the 4th, all raised to the 3rd power? This 3 would get raised to the what power? 3rd power. What would happen to this x squared? It would also get raised to the 3rd power, which means it's going to be x to the 6th power. By the way, what's 3 times 3 times 3?
Oh, wait.
27. What's the y going to be raised to?
4.
I got y to the 4th. Raised to the 3rd is going to be y to the 12th. Because what you're doing is you're taking the y to the 4th and also raising that to the 3rd power. If you see powers raised to powers, you multiply. So the 3 has to get raised to the 3rd power. The x squared has to get raised to the 3rd power, which means you go powers raised to powers, you multiply. And then, same thing here, you would end up multiplying the 4 and the 3. Are we good with those? All right, using those exponent rules. I could rewrite this, but this is actually a pretty good list. Everybody take a look at page 460. Page 460. That's weird. Okay. If you look right at the, guys, if you look right on page 460, there's actually a pretty good list that'll help you know, right in the middle, are we simplified yet? What's the first thing that you have to avoid? No negative exponents. We are not allowed to have something like 3 to the negative 2 power. If you see a negative exponent, you're not done yet. Okay? What's the next little tab? You have the same base does not appear more than once in a product or a quotient. Okay? Same base can't appear more than once. Basically, if you have 4x squared times x to the 3rd, you're not done yet. Because what can I do with the 2 and the 3 here? I could add them together. You're not done yet. This is a list to know I'm not done yet. Okay? You're not totally simplified if you see a negative exponent. You're not totally simplified if you see the same base, an x and an x, multiple times. Okay? You're also not done yet if you see powers raised two powers. You can't have something like, oops, that's not what I want. I want to erase that. You can't have something like x squared raised to the third. You can't have powers raised to powers. If you see that, you're not done yet. You can't see quotients. Raised to powers. There is one more kind of a, I guess you could write this as a second rule, but in fact, I'm going to write this as another rule. We're going to add one more rule to this. What do you think if x times y raised to the a power is xa, ya? What do you think x divided by y raised to the a power is? Take a guess. What do you think the x has to do? No. What do you think the x has to get raised to? So that means the x has to get raised to the a. What do you think has to happen to the y? It also has to get raised to the a power. So if you see something like two-thirds to the second power, that's the same thing as 2 to the second power over 3 to the second power, or 4/9. That's all it is. You just take that to the second power, that to the second power, you're done. So if you see a fraction where the whole thing is raised to a power, you're not done yet. You can easily take care of that. Okay? What's the last one it says there? Numerical coefficients in a quotient do not have the same. All right, so all that means is, where'd my list go? Here's a simple way to say the last one. Fractions must be reduced. All right, so let's try some of these. Everybody take a look at page 464. 464. In fact, let's start your homework. Your first problem in your homework is number 3. You might as well put this on a homework page. Not today. Oh, that's a bad day.
It says 1 through 7 through 1, 7 through worksheet.
That's tomorrow. There's,
4, 6, 4, 5.
yeah. All right, so number 3 says n to the 6 times n to the second. What's the only thing you have to do with those two numbers, those two exponents? Adam, what's the answer? N to the 8th. Number 6. By the way, we're doing every third. It says x to the second raised to the 5th power. What do you do with powers raised to powers? You multiply. What's the answer? X to the 10th power. Number 9 says 3 to the negative second raised to the 2nd power. I would do powers raised to powers first. What's the rule? Powers raised to powers. What do you do with the exponents? What do you do with the negative? You times them. Yeah, that's called wait time. I was waiting for you guys to talk. Negative 2 times 2 would be negative 4. We're not adding. What do we do with negative exponents? Because we're not done. You flip it, so the final answer should be 1 over 3 to the 4th. And by the way, my general rule of thumb of should I simplify the number? Use common sense. Is 3 times 3 times 3 times 3 a giant, giant number? Well, 3 times 3 is 9. The other 3 times 3 is 9. 9 times 9 would be 81. No. If the answer is going to be kind of a small number, a normal number, then yes, simplify it. If you get something like 2 to the 30th power, that number is well over 1 billion. No. Do you think I want you to multiply all that out and put all those zeros? Or do you think I just want you to leave it as 2 to the 30th power? Just leave it as 2 to the 30th power. So use some common sense. If the number is giant, just leave it as the exponent. If the number is 3 squared, no, just make it 9. We good so far? What do you do with 12? It says 2t to the 5th power. What do you do with that one? Is the answer going to be 2t to the 5th power like that? What did I forget? The 2 also has to get raised to the 5th power. And then this one, yes, I would like you to multiply that out. What is 2 times 2? Times 2? Times 2? Times 2. So that'd be 32 t to the 5th power. That would be the best answer. Okay, how about 15? Negative 2 x to the 5th all raised to the 3rd. What do I do now? So that's going to be x to the 15th, right? What about the negative 2? What do I have to do with the negative 2? I have to raise the negative 2 also to the, not the 15th, 3rd power. This x to the 5th has to get raised to the 3rd power. That 5 is only connected to the x. This is raised to the 1 power. Now, so that's where I get this. What do I have to do with this negative 2? Negative 2 times negative 2 times negative 2. What's 2 times 2 times 2? 8. Is this going to be positive or negative 8? Why negative 8? Because a negative times a negative times a negative, 3 negatives make a negative. Does everybody see where I got negative 8x to the 15th? You have a question? What's that? 44, yes, is already simplified. That one's done. That's the answer. So the answer to number 44 is x to the 5th, y to the x to the 6th, y to the 5th.
Can I grab my calculator?
Sure, but for what?
Because I'm done.
Like, honestly, I'd like to know what question you're using a calculator for. I mean, to me, the only thing to use a calculator for would be, like, if you were going to do number 18, where 18 says 3 to the 3rd times 2 to the 3rd times 3. Can I add all these exponents together? Why can I not add all these exponents together? Because they're not the same base. What are the only exponents I can add together? The 3 and the 1. So because I can go, that's the same thing as 3 to the 4th times 3 to the 3rd, or 2 to the 3rd. Now, the only thing I would say to use a calculator for would be maybe to do this. 3 times 3 times 3 times 3, that's going to be 81 times 8. Maybe you do 81 times 8 in your calculator. But that would be about the only thing I would use a calculator for this whole assignment. If you're just dealing with the exponents, I would not do those. Okay?